Today we'll be doing the integral from 0 to 1 of the natural log of x plus 1 times the natural log of x dx. And to start off, we will parameterize this integral. So we'll let I of a be the integral from 0 to 1 of the natural log of x plus 1, x to the a dx. And notice if we differentiate both sides, we have that I prime of a is the integral from 0 to 1 of x to the a ln x times the natural log of x plus 1 dx. And notice that I prime of 0 will be the original integral. So we have to first solve this integral, and once we do that, we will differentiate with respect to a and then plug in 0, and that will be the answer. So we said that I of a is the integral from 0 to 1 x to a times the natural log of x plus 1 dx. We could use integration by parts. So we'll let u equal the natural log of x plus 1, which means that du equals 1 over x plus 1 dx. dv will be x to the a, which means that v equals x to the a plus 1 over a plus 1. So we have I of a is going to be the natural log of x plus 1 times x to the a plus 1 divided by a plus 1 from 0 to 1 minus the integral from 0 to 1 of v, and then du, which will be times 1 over x plus 1 dx. So evaluating this limit, we have, plugging in 1, we have the natural log of 2 over a plus 1. Plugging in 0 will end up being 0. We could factor out a 1 over a plus 1 term, so minus 1 over a plus 1. The integral from 0 to 1 of x to the a plus 1 divided by x plus 1 dx. And we'll use the fact that 1 over 1 plus x is the sum from 0 to infinity, negative 1 to the k, x to the k. So I of a is the natural log of 2 divided by a plus 1 minus 1 over a plus 1. Integral from 0 to 1 of x to the a plus 1, and then the sum from 0 to infinity, negative 1 to the k, x to the k dx. And then swapping the sum and integral, we have I of a is the natural log of 2 over a plus 1 minus 1 over a plus 1, and then the sum from 0 to infinity, negative 1 to the k, then the integral from 0 to 1 x to the a plus 1 times x to the k dx. And from here we could combine the exponents. So we have I of a is the natural log of 2 over a plus 1 minus 1 over a plus 1, and then the sum from 0 to infinity, negative 1 to the k, the integral from 0 to 1 of x to the a plus 1 plus k dx. So we have I of a is log 2 over a plus 1 minus 1 over a plus 1, and then the sum from 0 to infinity, negative 1 to the k, we'll have a x to the a plus 1 plus k plus 1, and then divided by a plus 1 plus k plus 1 from 0 to 1. And this ends up simplifying into I of a is the natural log of 2 divided by a plus 1 minus 1 over a plus 1, and then the sum from 0 to infinity, negative 1 to the k, and we're going to have a 1 over k plus 2 plus a. So we left off that I of a is the integral from 0 to 1 of x to the a times the natural log of x plus 1, and it resulted into this expression, the natural log of 2 divided by a plus 1 minus 1 over a plus 1, and then the sum from 0 to infinity of negative 1 to the k divided by k plus 2 plus a. So we will start off from this where we left off. So I of a is now the natural log of 2 over a plus 1 minus the sum from 0 to infinity, negative 1 to the k divided by a plus 1 times k plus 2 plus a. And so we would differentiate both sides with respect to a, and from there plug in 0 because that is the original integral. So I prime of a will be log 2 and the derivative with respect to a of 1 over a plus 1, and minus the sum from 0 to infinity, negative 1 to the k, and then the derivative with respect to a of 1 over a plus 1 times k plus 2 plus a. So differentiating this piece, we have I prime of a is log 2 times negative 1 over a plus 1 squared. We'll have a minus the sum from 0 to infinity, negative 1 to the k, and differentiating this part will involve the quotient rule. So label the top f and the bottom g. So using the quotient rule, we will have a plus 1 squared, k plus 2 plus a squared. So we'll have a g term first, and then f prime, but f prime will be 0 because the derivative of a constant is 0, and minus f, and then g prime, this will be the derivative with respect to a of a plus 1 times k plus 2 plus a. So we're left off with this, but this cancels because multiplying by 0. So we're left with I prime of a is negative log 2 over a plus 1 squared, and minus the sum from 0 to infinity, negative 1 to the k times negative the derivative with respect to a of a plus 1 times k plus 2 plus a divided by a plus 1 squared times k plus 2 plus a quantity squared. And notice that this negative and this negative make a positive. So you have I prime of a is negative log 2 divided by a plus 1 squared, and then plus the sum from 0 to infinity, negative 1 to the k. And differentiating this, I'll label this f and g using the product rule. We have g and then f prime, and then plus f g prime will end up being 1 over a plus 1 quantity squared times k plus 2 plus a quantity squared. So now after differentiating, we have the following expression. We have negative log 2 divided by a plus 1 quantity squared plus the sum from 0 to infinity, negative 1 to the k, and then k plus 2 plus a plus 1 divided by a plus 1 quantity squared times k plus 2 plus a quantity squared. And notice we could break apart this fraction. So we have I prime of a is negative log 2 divided by a plus 1 squared plus the sum from 0 to infinity, negative 1 to the k, and then we'll have a k plus 2 plus a divided by a plus 1 squared, k plus 2 plus a squared, and then plus a plus 1 k plus 2 plus a squared. And now from here we could distribute. So we have I prime of a is negative log 2 over a plus 1 squared And then we'll have plus the sum from 0 to infinity, -1 to the k plus 2 plus a divided by a plus 1 squared, k plus 2 plus a squared. And then we'll have plus the sum from 0 to infinity, -1 to the k a plus 1 divided by k plus 2 plus a squared. And now that all that's left to do is to plug in 0. So I prime of 0 will be -log2, 0 plus 1 squared will be 1. So we have plus the sum from 0 to infinity. And notice that this one will cancel with this one. And plugging in 0, we have -1 to the k, 0 plus 1 squared, which is 1. And plugging in 0 here, we have k plus 2. Then plus the sum from 0 to infinity, -1 to the k divided by k plus 2 quantity squared. So now all that's left to do is to evaluate each sum. And before I do that, I will show a following identity. And to start off, we will consider the sum from 0 to infinity of a to the k plus 1. So expanding this, we just have a1 plus a2 plus a3 and so on. And the sum from 0 to infinity of ak plus 2, a sub k plus 2. But this will end up being a2 plus a3 plus a4 plus ... But now we will connect these two and notice that this term is part of this term. So that means that the sum from 0 to infinity of a sub k plus 1 is a1 plus the sum from 0 to infinity of a sub k plus 2. So subtracting a1 on both sides, we have that the sum from 0 to infinity of a sub k plus 1 minus a sub 1 is the sum from 0 to infinity of a sub k plus 2. So we said that I prime of 0 is -log2 plus the sum from 0 to infinity, -1 to the k divided by k plus 2, and plus the sum from 0 to infinity, -1 to the k divided by k plus 2 quantity squared. And we'll use this following identity to find the sum values. So for this first one, we will consider a sub k equals -1 to the k divided by k. And notice that a1 will be -1 to the first power divided by 1, which is -1. So using this, we have that the sum from 0 to infinity, a sub k plus 1 will be -1 to the k plus 1 divided by k plus 1 minus -1 equals the sum from 0 to infinity. A sub k plus 2 will be -1 to the k plus 2 divided by k plus 2. And so this will become a positive 1. And we could write this as negative the sum from 0 to infinity, -1 to the k divided by k plus 1 equals the sum from 0 to infinity, -1 to the k over k plus 2. But that's exactly the sum we're looking for. Oh, I forgot the plus 1 here. And we know this particular sum, it's actually -log2 plus 1. So this is the value of our sum. So that means that we have I prime of 0 is -log2 and then plus 1 minus log 2 And then we have a plus the sum from 0 to infinity of -1 to the k divided by k plus 2 quantity squared is equal to our integral, because we said the condition I prime of 0 is the original integral. And then we could use the same technique, but I won't show it, but the sum from 0 to infinity, -1 to the k divided by k plus 2 quantity squared will end up being 1 minus pi squared over 12. So using these values, we have that I prime of 0, which is the integral, is -log 2 plus 1 minus log 2, and then plus 1, and then minus pi squared over 12 is equal to the value of this integral. Now we all have to do is combine like terms. So the integral will now be -2 log 2 plus 2 minus pi squared over 12, which is the value of the integral from 0 to 1 of the natural log of x plus 1 times the natural log of x dx. And so this is the final result. Thank you very much for watching.